Okay, so the last thing we are going to do is graph a quadratic inequality. So this is similar to what we did before. So let's not just get tricked because we have a less than sign there. We're still going to find the same things as we did before. And then we are going to graph, but then we're going to go back to our inequality that were linear, where if we have just a less than or greater than symbol, we're going to have a parabola and it's going to open up or down, but it might, this one's going to open down because A is negative. It's going to either be a boundary, so dashed, or solid. And so in this case, it's going to be dashed. If it's less than or equal to or greater than or equal to, it's going to be solid. So first, let's identify the y-intercept. The y-intercept is still our plus the end. Okay, so remember, A is the coefficient of x squared, B is the coefficient of x, and C is the constant. So this is going to go through 2. We already indicated that since A is negative, this parabola is going to open down. So let's go ahead and find the axis of symmetry. So like before, we're going to take, to find the x equals, we're going to take the opposite of B over times A, and we're going to be careful here because B already is negative 6. So the opposite of B would make it positive 6, and then 2 times negative 3 would make this negative 6. And we want to try to do as much math as we can in our head so we save ourselves from calculator error. So we have 6 divided by negative 6, which is negative 1. Okay, and so when I'm graphing this, I know that x equals negative 1 is going to cut that parabola in half. When I know symmetry, what I also know is I know that the vertex has an x coordinate of negative 1, so I don't have to do that work again. All right, now I'm and find the y coordinate of that vertex, and so I'm going to plug in negative 1 into my function up here. I'm going to pretend for now, since I'm trying to graph, that this is an equal sign. I'm going to save this dashed business for a little later on, and so I do that. And again, if I'm going to use my calculator, I'm going to make sure I have parentheses, so I plug negative 1 in for x, so I'm going to square it. Minus 6 times negative 1 plus 2. All right, so I'm going to try to do this in my head. Negative 1 squared is 1 times negative 3 is negative 3. Negative 6 times negative 1 is plus 6 plus 2. So look, it would be 5. All right. So I think I have enough information to graph my parabola. The last thing I'm going to have to do is shade. Okay, so let's put some things on. So we're going to go ahead and put our vertex on. Our vertex is negative 1, 5. And so we know the turning point of our parabola. So either it's the turning point and it's a minimum, and it's or it's the turning point and it's a maximum. We know that this parabola opens down, so we know that this is going to be a maximum. That will help us as we're graphing our parabola. Here are some other things we know. We know that the y-intercept is 0, 2. We also know, because it's negative 3, if we were to graph points 1 away, they'd be down 3. It happens to be that that confirms what our y-intercept is. If we use symmetry, parabolas are symmetric. They do the same thing on either side of the vertex. So if my parabola was going to come down onto this side, it would also go through the point 2, 2. So then I'm going to go ahead and I'm going to graph this parabola, but instead of using a solid, I'm going to use a dashed parabola. So it looks something like this. Make sure I have a curve to it and comes down like this. Okay. And so when I'm doing shading, I'm going to think of the interior of the parabola. So the interior between these branches and down, or the exterior. And maybe you remember, how do we choose? Well, is it either going to shade on the interior of this or on the exterior of the parabola? We usually test a point. Same thing, I'm going to test this point 0, 0. And if 0, 0 is going to work, then that means that I am in the correct solution. This is on the interior of the parabola that I'm going to shade there. If it's incorrect, that means that I need to shade on the other part. We test. I test 0, 0. I go back up here. So I get 0 is less than, let's see, if I put 0 in for x, that would make this 0. That made this 0. This would still be a 2. Is 0 less than 2? That is a true statement. That means that I am in the solution region. I am interior of that parabola. So adding an inequality graphs changes the graph. You still have to find the things that we found above, but it just adds that extra piece of making it solid or dashed and shaded.